Welcome back. Today we're going to be taking a look at this power supply that I've actually modified. And well, basically the reason why I modified it was this was originally a 12 volt 3 amp unregulated power supply. And when I say unregulated, that means it's basically just a transformer and a couple components to kind of reduce the voltage down, transform it from AC to DC. Nothing special. And the problem I had with it was it's a 12 volt unregulated supply, as it said, but you're actually getting 16 volts out of it. And that 16 volts, you know, with a lot of these supplies, when you give it a load, it will actually drop down to the proper voltage. And that was not the case with this particular supply. And I felt that, you know, a lot of the things I do, I would rather have exactly the voltage I want. And when I did the modifications on this, I already, you know, I had an idea of how to do it. You know, you can get like an LM317 linear regulator, or a 7805 or 7812 regulator, and kind of just cobble it into the circuit, and it wouldn't be that hard to do. And I figured, well, I can do that, and I had this thing lying around, so why not try to do it? So with that, I kind of want to walk you around this thing and give you an idea of what's involved in it. Now, this originally came from RadioShack. I've actually had this for quite a while. In fact, I opened it up and saw a date code from 1998 inside of the thing. So, and this being 2016, you can imagine it's fairly old at this point. But nonetheless, I do have a schematic that I sketched out here to show you what it originally looked like, since unfortunately I don't have any pictures before I did the modification. Let's see if I can get this to stand here. And it's a very, very basic design. We can see here we have the AC coming in. Now, I didn't mark line or neutral on this, or, you know, just left it as is. It comes into a indicator, like a neon indicator power switch, that when you turn the switch on, the neon lights. And it goes directly to a transformer. And this is where it was getting the 16 volt reading. So you're stepping down the, in this case, 120 volts down to 16 volts. And it remains AC. It comes through a 32 amp 3 amp circuit breaker that's mounted on the back, and then it went to a standard bridge rectifier, in this case a 600 volt 3 amp bridge rectifier. It went to which I should say, which converts this to DC, and then in between the positive and negative rail was a 25 volt 4700 microfarad capacitor. And then there was also a 680 ohm 5% tolerance resistor kind of across the leads too. And then that's basically your, you know, your positive and negative rails. And there was a cigarette lighter in the front, and then the terminal in the back, and that's where you're getting your, you know, about 16 volts out of. And, you know, that's pretty much all there was to it. There wasn't a fan or any kind of active cooling, anything at all like that in it. No heat sinks, nothing. Just a transformer, a rectifier, a capacitor, and a resistor. Basically the most simple form of power supply you can get. You know, this isn't a switched mode supply, nothing at all like that. So when I took a poke at it, I figured we could make this a little better. So here's the unit. And you can see, obviously, I did do quite a bit of modifications to it. Now, here's the original power switch right here. There is another switch on here which actually changes the speed of the fan on top. It did originally have this jack here, which is your typical, you know, DC 12 volt jack like you'd have in your car. You'd plug a cigarette lighter into, or a charger for your phone. And that's more or less what this was used for. You know, it's kind of like a benchtop supply for testing cell phone chargers out, and, you know, small 12 volt projects. And then on the back, see, obviously this is your AC in cord, and there's these speaker terminals. Now right now there's 4, but originally there was only 2, and they were the same kind of spring loaded, but they were, you know, side mounted, so there was a lever on one side and a lever on the other with the 2 terminals in the middle. And then you have your 3 amp breaker. And I did label this, but this is, you know, before I actually had a label maker, so I do have the paper labels. And this actually was originally 2-tone. This middle part here was actually a gray color, and then the outer case was the black. And then right over here I had the RadioShack logo 12 volt 3 amp power supply, and it didn't mention unregulated or anything. It just said it was a 12 volt power supply. And back before I really knew much about anything, I just took it for granted and never really used it. Then I plugged my trusted meter into it and I found out, oh, I'm getting 16 volts out of this thing. I could be frying a lot of stuff. And I decided just to go the regulated route, as I mentioned. So without opening it up, I'm going to go ahead and show you what I did. Now, my hand-drawn sketch that I showed earlier worked for the original kind of concept, but I found that once I started drawing out the regulation part and everything else, it got a little bit complicated. So I just kind of went to software, and I used some free software I downloaded from PCB Express, which is a company you can download the software from, make your project in a schematic, and then also make it in a PCB design software. There's two pieces. Then you would upload the design to their website and then get a printed PCB from it. I've never actually honestly used that service, because most of the time I just use this program for sketching out things. And well, I'll show you. This is the schematic view of the original design that I showed. Hopefully I can get this to come up on the camera clearly enough. The problem with it was the scaling. It looked great on the computer, but it kind of gets a little small here. This is the same concept as this drawing, but what I did was, on the DC side, instead of drawing all the lines for the ground or the negative rail or whatever you want to call it, I just went ahead and just drew the ground symbols instead. So this would be the terminal that was in the back. This is the barrel plug for the cigarette jack, your capacitor, your resistor, your diode, the breaker, the transformer, and then of course the power switch in the input. So that's the basic design. This, however, is the updated design, which hopefully, again, you can make this out in the camera given the angle. And simply all I did was, on the output rails from the original capacitor and resistor, I put a 7805 and a 7812 rectifier. Obviously the 7805 is going to give you 5 volt and the 7812 is going to give you 12 volt. And if you look at the data sheets for these two regulators, you'll notice that they mention putting in a couple capacitors in line with the input output rails, and then you tag them out to the ground. And those are like coupling capacitors, and you use them just to smoothen out the signal, as is the main 470 or 4700 I should say microfarad capacitor. It's just used to smooth out the signal. And whether or not they're actually needed or not, I'm not 100% sure. I'm not an electronics design guy. I just followed what the data sheet had on it, and I've actually been doing that same design on all the regulated units that I put together. And well, it works. It's not the most efficient thing, but then again, linear regulators aren't efficient anyway. That's why we have switched mode power supplies. But linear power supplies are a lot cleaner when it comes to like audio circuits. I tend to find that a lot of the amplifiers that I play around with get a good buzz noise when you hook them up to the switched mode power supplies, where the linear supplies, they don't. So this is great for testing things out like that. But it's a very simple concept. All I did was just added 2 LEDs just to show that the rails are actually working. I changed the jack in the back to be a 4-conductor jack instead of a 2-conductor, since there's 2 different voltages. I put a USB port in the front of the unit, and I also put the fan selector switch, which is basically switches between a 5 volt and 12 volt rail, so you can run the fan at low speed or high speed. It's a very simple concept, nothing too complicated. What I'll try to do is make a screenshot of this and just put them at the end of the video so you can get a clear shot of what they look like. But well, enough of the theory and schematics of it for now. I'm actually going to just back this out just a little bit and show you the main unit itself. Now, I wouldn't necessarily call this finished, nor would I call it perfect. My skills in the design area of things have gotten a lot better since I made this. Originally I used a two-sided, just generic like perf board kind of thing, and there's wires all over the place in this. What I would like to do with it is actually have a circuit board designed for it by using the schematic I already came up with, or you know, just design one from scratch. Either way, but I'd like to make up a board or have a board ordered for this, and you know, kind of like neaten it up a little bit. But you can see on the front here we do have the USB connector. Here's that switch I mentioned. There's the 5 volt and 12 volt good rails. They actually need to be reversed. On the back we do have that 4 terminal unit, and then the fan on the top. Now the fan does need to have a guard applied to it. You know, the fan was actually an afterthought because the linear power supplies, in order for them to work right, you know, you're basically dissipating the extra voltage and heat, and both those regulators are on at the same time. So you could plug something into the 12 volt terminal and you could plug something into the USB port at the same time and use them both. But the problem is maximum current. This thing was rated for 3 amps, whereas the linear regulators in here I think have a 1.75 amp top, you know, range. So that was kind of the limiting thing. But you know, charging a cell phone off of it wasn't really a big deal. Now obviously today we have smartphones and tablets and stuff, so that draws a little bit more. In fact, most of those chargers are like 2.1 amps. So right there it's kind of a little obsolete, I guess you could say, in that regard. But for other things it works great. You know, it's just a little simple power supply anyway. And it was more of like a proof of concept just to see that I can do this. But I'm going to go ahead and plug this in. I do have a little outlet off to the side here, and show you just a quick operation of it. Like I mentioned, you could turn the power switch on and you see the little neon bulb in there glows, and then you have the 2 LEDs that indicate that the both rails are on. And right now the fan is running on its slowest setting, which is the 5 volt. Ideally, I guess I could make a switch where the center position would be off, so if I wanted to shut the fan off I could. But you know, I did notice that it got warm, and like I said, the fan was a bit of an afterthought, so I kind of added it in at the end. If I switch it over to the 12 volt rail, you can see it's quite loud. This was actually a Delta fan that came from a computer power supply. There were 2 of them mounted side by side, and when the power supply got warm, I should say, it would kick onto this higher speed, and sounds like a little jet engine going off. But it definitely did the trick and cooled down the unit pretty quickly. So I figured it would be great for this unit, especially if I was using a higher load. Now it is worth mentioning, when you're using the fan on high speed, you're going to draw from the 12 volt rail, so that's current you're taking away from something else. And likewise, you know, same thing with the 5 volt rail. So if you were using this to charge a phone and you were finding it was getting warm and you kicked it over to the 12 volt, you're actually drawing current from both rails pretty good, and it did get pretty warm. But you know, judging by the amount of airflow coming out this thing, I mean, you can feel it. You could feel that fan blowing out the sides of this thing, so it worked really well. But I'm going to go ahead and shut this off and take it to bits, and just save you the boring parts. I'm just going to pause the video here and come back to when it's open. There's just 2 screws on either side that are going to come out. Now, interesting, I will mention that they did use the square bits, the Robertson bits on this. And when I put this back together after I was done with it, I lost one of them. So one of them is actually a Phillips head. But I'm going to go ahead and take that apart, because if you don't know how to undo a screw by now, this probably isn't the channel for you. But at that rate, we'll be right back. Alright, screws are out, and then the top just simply lifts off. And I did leave enough of a wire on here so I could put this to the side without having to disconnect anything. And the pieces that were original to this were the big transformer that you can obviously see right over here, and this blue capacitor, which originally sat in the back, connected directly to the terminals in the back, and the resistor was kind of just strung across the top of it, and that was also connected to it. And that was it. There was no circuit board inside this thing or anything at all like that. which was actually quite surprising. But then again, really, with such minimal components, why would you need a actual circuit board or anything like that? But I'm going to go ahead and try to zoom in here as best as I can, just to go ahead and show you, more of the insides. Now, I did mention there are wires kind of jumping all over the place in here. Partly because of the fact, like I said, the fan was an afterthought, and well, the LEDs were kind of a little bit of an afterthought too. But such as with experimenting and designing these things, you kind of piecemeal it like that. Now, the USB, we'll start up here, is actually from the back of a computer. You're gonna get these PCI slots, which you have 2 USBs just in a simple little slot. I bought a bunch of them off of eBay a while back, real cheap, and I just been just taking the actual connectors off and just using the raw ends of it, and that just connects to the circuit board, nothing special. And everything in here is heat shrinked just to make sure it's safe. I don't want anything shorting out on me. I mean, even the power switch has nice heat shrink on it. That's a practice I've always been following. I like the way heat shrink works, and it just, like I said, keeps things safe. And if you open this thing up, you don't want to go ahead and shock yourself or anything like that. And it's a good practice to get into. But I will mention, it didn't have any heat shrink on it before. It was just kind of cobbled together, honestly, rather cheaply. But I did put a lot more thought into it than originally intended. But then again, these things are consumer items. They are built to a cost, which would make sense, It was, I wish I remember how much it was, honestly. It wasn't a whole lot of money when I bought it. I did buy it new. I just needed a little power supply for stuff and went with this. But anyway, enough about that. You can see over here the circuit board that I put in. Again, it's just a simple perf board. Nothing spectacular. The big capacitor kind of just sits from side to side, so I considered one side of the board the positive rail and one side the negative rail. And that is a Nikon capacitor, which is a surprisingly pretty good capacitor that they use in here. It wasn't cheaply put together in that regard. But yeah, this is just extra wire. I wasn't going for pretty, I was going for function more than form, I guess you could say. Ultimately, like I mentioned, I would like to go ahead and neaten this up a little bit. I did have to originally take the transformer out and mount it sideways like this. It sat, oriented like on a 90 degree. It was sent the other way. I do have heat sinks on the 2 regulators because they did get quite warm. And you can see I kind of had to bend this one back a little bit just to get the fit. And well, that really is all there is to it. I mean, it's nothing too spectacular in here, but I did want to point this unit out. It's been sitting on my shelf and I've been looking at it and doing all these videos. I've been wanting to find subject matter to do, and I thought this was a pretty neat thing to look at. It's really not hard to convert these things over as long as you're within the power requirements of the original unit. Now, I have in the shed a big 30 amp 12 volt unregulated supply. Obviously, that's going to entail different circuitry to get that to be a regulated supply. And that's a little bit beyond the scope of my knowledge. But eventually one day I might work on something like that because it'd be a neat thing to work on. But this is just using these, like I said, the 7805 and the 7812 regulators and just this TO220 package. I will put links to the data sheets in the description below, as I always try to do. And that's really all there is to this. Now, you're probably wondering where the bridge rectifier is. It's actually on the other side of this board. And you can see that there's this one singular screw right over here. And that's threaded right through. So I'm going to go ahead, I'm actually going to take that one screw out. We'll show you the other side of the board as well. And I have to plug my camera in, actually. From doing all these videos, the battery life in this thing's just been not the greatest. And on a full charge, I don't get very long to record these things. So yeah, I'll get that thing taken out. I'll whip this into the charger real quick and we'll be right with you. Alright, here's the little circuit board loose. And if I flip it over here, you can see here is that bridge rectifier, and the hole was actually, this was mounted into the case, and there was just wires soldered to the pins of it. Again, no circuit board needed, just a bunch of wires running back and forth between the transformer, the capacitor, and the terminals in the back. And that was all she wrote. And I did kind of stay with the two-sided design. You can see there's a lot of wires running back and forth between the different rails on both sides of this board. And it was kind of one of those things, it was exploratory, you know. As I took this thing apart, I was trying to figure out how it worked, what each component did, and how I can add the regulators into the circuit. So it was kind of a trial by error thing, trying to figure out how to fit these pieces in. Well, first of all, I had to desolder everything that was in there and then kind of lay it all out and figure out what I was working with. And it was a bit of reverse engineering. Now keep in mind, this was put together a while ago. I mean, I've been living here 7 years, 8 years now, and it was right around that time. I had a little thing set up in my shed outside, and that's one of the earlier projects that I worked on here. I've always been into electronics, just never really on a formal level. And, well, this is about as formal as I guess I can say I've been on the subject of it. But this was one of the earlier things that I worked on. So, yeah, it's definitely not a pretty design, but it works. And it works pretty well. And eventually it will be redone. And for sure I will have some kind of a video based upon that. I mean, I already have the schematic drawn up in the computer, which I put together last night actually. And it's just a matter of importing that schematic into the PCB design program, and then I can go ahead and design an actual board. And I, you know, never really etched my own board or never had them ordered, but for this particular project I might try this. This might be a starting off point just to get this thing, you know, going and try to design it maybe a little bit better. You know, did I need to put a coupling capacitor on each regulator? I don't know. You know, the original design had one across the leads for the positive and negative rail, and I know why that was there. Fundamentally, I understand why the schematic for the individual units have it. But as a whole, you know, usually you need those the further away you are from the main power supply. Being that they're all within the same unit. Again, is it necessary? I don't really know, but they're there anyway. They're jelly bean parts, as I hear people say. They're super cheap, so why not add them? And oh, I should mention the readings on those. On the inbound side of the regulator, it's a 0.1 nanofarad 50 volt, and on the outbound side it's 100 nanofarad 50 volt. And I just went with those numbers because, well, like I said, the data sheet suggested them, but on the other end of it, you want to go with a higher voltage rating than your project's handle. So knowing that this was a 16 volt unit here, doubling that would give you 32 volt, which is why they use a 32 volt circuit breaker. And I figured we'll keep within those numbers, and why not go a little higher than that and get something in the 50 volt range. Now the original capacitor that was used in here, this big Nikon jammy on the side over here, that's a 25 volt unit, and you know, it fits the bill fine because it's still higher than what it's rated for. But you know, what are you talking difference in price? Not much. So I just went with the higher voltage rating. Well, that's, you know, really all she wrote. I mean, I can go ahead and put a meter to this, but I can already tell you it's pretty damn close to the 12 volt and 5 volt rating. And that's right where I want it to be. You know, it's a great cell phone charger. I've used it for that quite a bit. I've used it to power, you know, LED circuits and a variety of other things. And while it's not, you know, a beast as far as, you know, some of the other supplies I build, it holds its own and it has its usage. So I'm going to go ahead and put this whole thing back together again, and that's really all I have to say about this project. Hopefully in the coming months I'll have some kind of an update where I can show you how I've redid the entire thing again and made it, you know, not so wiry and kind of cluttered up in here. But you know, this is how you learn electronics. You buy yourself something like this and just tear it apart, open it up, and reverse engineer it. Just follow, you know, follow the AC line in, and just go from there. You know, I can give you a quick rundown on this board because the schematic may not make sense to a lot of people, but it may make more sense this way. But it's simple. I mean, the AC comes in through this wire here. It goes up to the switch in the front. When you turn the switch on, it sends the AC out to the transformer, as you can see by the two red wires. They are non-polarity sensitive. You can put them either way. This is an AC transformer, so you're taking the 120 volt down and bringing out 16 to it. Then that goes directly to the circuit board. There is a positive and a negative rail, and they're, you know, hooked up with the capacitor is hooked up in parallel with it, as is the resistor, which you can't see, but trust me, it is down here in the board next to the capacitor. And then the input of each of the linear regulators is hooked up to the output of the rail. The ground's hooked up to the negative side of the rail, and then the outputs of their own have their own individual rail. So there's a 5 volt rail and a 12 volt rail on this board. Then the fan wires and the LED wires are connected to those as well. They go up to the switch. The USB output and the 12 volt regulator output in the front hook up to the 5 volt and 12 volt rail respectively, as does the piece in the back. And the circuit breaker, that actually sits in line, so the output from the transformer goes into the circuit breaker, and then from the circuit breaker out to the board. So that kind of just sits in between it. So in case you just draw too much amperage, this thing just pops and you can just reset the switch once you fix the problem. So it's a very simple design, very easy to understand. It's certainly a lot more easier than a switch mode power supply. And I recommend, you know, picking yourself up one of these cheap supplies and opening them up and figuring out how it works. That's all I have to say about this video. I thank you as always for watching. My subscriber count is happily climbing. I believe I'm up to 31, which is a big jump from the last video I did. Well, big jump for me at least. And I'm very happy to see that. I definitely will be doing more of these videos. I have some pieces coming in to work on, which we'll obviously do some stuff on. And I'll have a few more of these power supply videos because I do happen to like my power supply stuff. And some LED projects. And well, that's really all I have to say. Thanks for watching. See you next video.